Under your sink, there is a U-tube shape connected to the rest of your plumbing system. When water is sent down the drain, the U-tube fills with water and exits when the rise in the water level reaches the vertical portion of the pipe at the opposite end of the U-tube. When the water is shut off, water remains inside the U-tube. The water in the tube on either side evens out to a point that is called a draw grade line. The force, mg, is the most important force that allows the water to remain in the U-tube.
There are also two other forces that come into play. One of the forces is due to atmospheric pressure that acts on either side of the water level, but is negated since both ends of the tube are open. They balance each other out. The second is the force that is exerted by gases from the rest of your plumbing system, travel back through the pipe, and are stopped by the water trapped in the U-tube. The force that the gases exert on the pipe is less than the gravitational force and atmospheric pressure keeping the water in the pipe.
If the gases were to build up enough pressure in the sink to overcome those forces, the water in the tube would be forced out of the tube, and the gases be released into your home. Although this seems very trivial, this system is overlooked by many people. Without this tube under your sink, toilet, or any drainage system, the gas given off by the decomposition of sewage in your septic system that your hose is connected to would be able to freely flow in your home.
Another purpose for the U-tube that is not directly related to the fluid within the pipe is a protection for people who drop something down the drain. Often objects that are dropped have a high gravitational force than the buoyant force of water. This object will sink and become trapped in the bottom of the tube, preventing that object from passing through and getting stuck somewhere further down in the plumbing system. This intention alone has saved people the hundreds of thousands of dollars to tear apart their entire plumbing system in order to retrieve the objects.
So in our slides we have the first example up at the top. Right here is just your basic sink U-tube where it's showing your atmospheric pressure on both sides, which would be equaling each other out, and the force of the water and the gravitational pull pulling down on it. This is an example down here that shows if there's a clog above the right side of your sink U-tube, that the pressure would alter due to the atmospheric pressure not being able to get up the right side of your tube, which then would result in a height rise in your fluid, and eventually it would fill up to the top and then backwash up into your sink, and then that would cause flooding. We also showed that at point 1 and point 2, the pressure points here are equal, and the height difference due to the pressure change can be calculated by solving for H, where it be the atmospheric pressure on the left side, subtract, and then minus your pressure on your right side, divided by the density of your fluid times G, with 9.81. In conclusion, without any of this basic engineering knowledge, most of the homes in today's society would be uninhabitable.